Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. OsO4-mediated dihydroxylation proceeds via a concerted 3+2 cycloaddition mechanism, delivering both oxygen atoms to the same phase of the alkene, SYN addition. The cyclic osmate ester shown is the intermediate after OsO4 has already added across the double bond of 1-methylcyclopentene, or the relevant alkene bearing two methyl substituents on adjacent carbons. Hydrolysis of this osmate ester under KOH-mannitol water conditions cleaves the OS-O bonds while retaining the stereochemistry established during the SYN addition. Step 1. Identify the substrate. The osmate ester shows a cyclopentane ring with two adjacent carbons bearing methyl groups, one on wedge, one on dash at those two carbons, connected via two oxygens to osmium. This represents the product of OsO4 adding SYN across the double bond of 1,2-dimethylcyclopentene, or equivalent alkene with methyl groups at the two carbons of the former double bond. Step 2. Hydrolysis of osmate ester. Treatment with KOH-mannitol water. The upjohn-type workup cleaves the cyclic osmate ester to give the SYN diol. Both OH groups are delivered to the same face of the ring. The methyl groups remain in their original configuration. Step 3. Determine stereochemistry of product. Since OsO4 delivers both oxygens SYN, same phase, the two OH groups end up CIS to each other. The two methyl groups, being originally on adjacent carbons, with one on wedge and one on dash, remain as such. The product is the CIS 1,2 diol where both OH groups are on the same phase and both CH3 groups are present on the adjacent carbons. Step 4. Match two options. Option A shows a trans arrangement, one on wedge at left carbon, one on dash at right carbon, indicating opposite faces. This would be the antidiol product, not from OsO4. Eliminated. Option B shows both CH3 groups and both OH groups, with OH groups appearing on the same face, CIS diol, consistent with SYN addition. This is correct. Option C shows no hydroxyl groups, elimination product, not a diol. Eliminated. Option D shows a ketone, cyclopentanone with gem-dimethyl. This would arise from oxidative cleavage, not simple hydrolysis. Eliminated. The SYN dihydroxylation product from hydrolysis of the cyclic osmate ester is the CIS diol shown in option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.